At 200 meters below the surface, red light disappears, pressure triples, and strange predators lurk in the blue-black gloom. That is just the first step. The deeper you descend, the more anglerfish twist their bodies and evolve weapons nature rarely dares to invent. Luminous lures powered by living bacteria, teeth that fold inward, and stomachs built for starvation. But at the abyssal edge, where flesh and bone barely hold together, you will find a creature more nightmarish than science fiction ever dared. If anglerfish adaptations get creepier the deeper you go, what does survival look like at the very bottom? Descending into the ocean, the world changes with every 100 meters. At 200 meters, the mesopelagic zone begins, often called the twilight zone. Here, sunlight is already fading, and the color red is the first to vanish, leaving only blue wavelengths to reach any further. By 500 meters, almost all color is gone. At 1,000 meters, the start of the bathypelagic, sunlight disappears entirely. Pressure mounts relentlessly. Every 10 meters adds another atmosphere, so by 1,000 meters, the force is 100 times what we feel at sea level. Water temperature drops near freezing, and the darkness becomes absolute. Even the most basic senses, sight, touch, and balance, are challenged in these conditions. Dr. Tracy Sutton, who has spent years studying these depths, describes it as a place where the rules of the surface no longer apply. The scarcity of light and the crushing weight of water define what can survive. Only the most specialized life forms persist here, forced to invent new ways to sense, hunt, and hide in a world ruled by pressure and shadow. The signature feature of the anglerfish is a living lure, a slender extension of the dorsal spine called the elysium, tipped with a fleshy bulb known as the esca. This glowing beacon is no ordinary tissue. Inside the esca, an entire community of bacteria from the Vibrianaceae family lives in symbiosis with the fish. These microbes emit blue-green light, a wavelength that travels farthest in seawater, making the lure visible even in the blackest depths. The esca itself forms a sealed cavity, lined with reflective and filtering structures that help shape and direct the glow. A WHOI microbiologist once described the relationship as a private lantern grown from a bacterial alliance. The fish can flex and pulse its elysium, mimicking the twitch of small prey. For passing crustaceans and fish, the light is irresistible, a fatal curiosity. The same lure may also help anglerfish find each other for reproduction, broadcasting a signal in a world where mates are rare. This biological flashlight is the first rung in a ladder of adaptations, a tool perfectly tuned to the physics of deep-sea darkness. Every feature of the anglerfish's body is a direct response to the deep sea's relentless scarcity. With food so rare, these fish are built to stretch every calorie. Their bodies are more gelatinous than muscular, a strategy that saves precious energy and allows them to float with minimal effort. Bone is kept to a minimum, replaced by flexible cartilage and connective tissue. This skeletal reduction not only resists the crushing pressure of depth, but it also makes the fish lighter, so they can hover in place for hours, waiting. Their mouths are a study in excess, enormous and lined with rows of needle-sharp teeth that curve inward, trapping anything unlucky enough to get close. When prey does appear, the jaws swing wide and the expandable stomach swells to fit meals nearly as large as the fish itself. One good catch can last for weeks. Between hunts, the anglerfish's metabolism slows to a crawl. They spend most of their lives suspended in darkness, conserving energy, poised in perfect stillness. An ambush artist shaped by famine and the void. A shape hangs in the blackness, barely outlined by the faintest shimmer from its own lure. This is Melanoxtus johnsonii, the black sea devil. Its silhouette defies the expectations of a fish, a swollen head, a cavernous mouth lined with translucent fangs, and a thread-like spine that arcs forward, tipped with a ghostly orb. The rest of the body seems to dissolve into the void, as if it were made from darkness itself. The secret is in the skin. Under a microscope, the sea devil's dermis reveals a dense forest of rod-shaped melanosomes, packed so tightly that light entering the skin is trapped, bounced, and absorbed in a maze of pigment. Laboratory measurements show these layers reflect less than 0.1% of incoming light, lower than any ordinary black fish. Even a direct flashlight beam disappears, swallowed by the ultra-black surface. This optical stealth is more than mere color. It is a survival tactic, rendering the fish nearly invisible to both prey and predators in the abyss. Against this black backdrop, the lure becomes a spotlight on a pitch-dark stage. The glowing esca hovers, isolated, while the body behind it remains undetectable. Any animal drawn to the light sees only the bait, never the jaws waiting in ambush. The sea devil's outline, all angles and emptiness, is the product of 1,000 adaptations for concealment. In the deep, where even a glint can mean death, being seen is not an option. Here, the monster is a shadow, and the shadow is almost perfect. A flicker of movement draws attention in the gloom. The black sea devil hangs motionless, its lure pulsing with cold light, every muscle primed. The esca dances, sometimes in slow hypnotic sweeps, sometimes with a sudden twitch that mimics the frantic dart of a tiny shrimp. Prey in the deep rarely get a second chance. Here, a single misjudged approach spells the end. In November 2014, a remotely operated vehicle from the Monterey Bay Aquarium Research Institute descended to 600 meters in Monterey Canyon. The pilot's voice crackled over the feed. The pilot said they could not believe they were seeing Melanocetus alive in the open. The remotely operated vehicle's lights caught the sea devil in profile, its jaws closed and its lure glowing. Then, as a small fish drifted too close, the sea devil's entire head seemed to unhinge. Jaws swung open to an angle wider than the skull itself, over 120 degrees, revealing a cavern lined with inward curving fangs. The strike lasted less than half a second. With a single gulp, the jaws snapped shut, teeth locking like a cage. The prey vanished, swallowed whole. This is not the explosive snap of a barracuda, rather a trapdoor, powered by flexible bones and gelatinous tissue, built for maximum expansion and minimal effort. The extendable jaws and distensible stomach allow the sea devil to eat prey nearly its own size, a necessity in a world where meals are rare. Moments like this, captured on high-definition video, are vanishingly rare. For the scientists watching it was a career-defining encounter, a glimpse of predation perfected by darkness and scarcity. Eyes alone are not enough in the deep. The black sea devil's retinas are tuned to fleeting sparks of bioluminescence. But most of the time, vision fades into uselessness. Instead, the fish relies on an ancient system called the lateral line, a series of tiny pores running along the head and body. These pores house mechanoreceptors that sense the faintest changes in water movement. A shrimp's panicked flick, the pulse of a swimming fish, and even the subtle wake of a potential mate all send vibrations through the water, instantly mapped by the anglerfish's nervous system. In total darkness, touch and vibration become the language of survival. In the deep sea, finding a mate is almost impossible, so anglerfish have rewritten the rules of reproduction. The male, a fraction of the female's size, locates her by scent and bites onto her skin. Over time, his tissues fuse with hers, blood vessels intertwining until he becomes a permanent appendage. He loses his eyes, fins, and even most internal organs, reduced to little more than a living sperm supply. Some females carry as many as 6 fused males, each a testament to the scarcity of encounters in the abyss. This merger is possible only because anglerfish have shed key parts of their immune system, allowing foreign tissue to integrate without attack, a biological gamble that pays off in total darkness. Cells in the deep sea face a constant threat of collapse under pressure. Many deep-sea fish defend their proteins with piezolites, small molecules that keep enzymes stable when everything else would fall apart. Flexible cell membranes and cold-adapted enzymes help anglerfish survive where ordinary chemistry fails. Every year, new remotely operated vehicles plunge deeper, revealing anglerfish more alien than fiction, right here on Earth. As we explore further, each adaptation forces us to rethink what life can actually survive. The deep ocean is not just strange, it is a reminder of how much we still do not know. Thanks for watching.